Hello everyone. Today we are going to see concept of impact. Impact is nothing but collision between two bodies for a short time of interval. So for this interval, both the bodies will exert large amount of force on each other. So there are various concepts impact. So we'll understand it deep. So first is line of impact, direct impact, impact and central impact. So to understand types of impact, first we will understand line of. So line of impact is nothing but the line on which impact takes place, or we can say it is line is perpendicular to the plane of contact. So plane of contact, this vertical line is plane of contact, which is nothing but on plane on which two particles taking impact, and this horizontal line is our line which particle is colliding on each. So basically there are two types of impact. One is direct impact, second is oblique impact. So direct impact means particle collides on each other on same line of impact, or we can say the velocities of both the particle are on same level. That is your direct impact. Oblique impact is nothing but the velocities are acting on different line, or you can say velocities are acting other than line of impact. So we can clearly see velocity v1 and v2 is acting other than our line of impact. So these are the two types of basic impact. Central impact. So central impact is nothing but the CGs of two bodies are on same line of impact. So we can see this G1 and G2, that is on same line of impact. That is our central impact. Now we will understand the concept deformation and time of deformation, restoration and time of restoration. So this is graph which is showing deformation and restoration and time required for it. So first we will understand what is deformation, what is restoration. So if you are considering there are two bodies A and B which is moving in same direction. So body A or particle A which collides on B, so for certain time there is change in shape of particle A. We can clearly see this second figure. So there is some sort of change in shape of particle A, and also we can say particle B. So this is nothing but the deformation, and after impact takes place, again they will regain their original size and shape. So this is your restoration. So by this graph we can see from time 0 up to time t, that is maximum deformation takes place, and after deformation takes place, so restoration process starts and it will again comes to its original. Now next concept is coefficient of restitution. So coefficient of restitution, it is ratio of impulse during restoration period divided by impulse during deformation period. Now we will see this concept, what is restitution. So we can consider this case, particle A and particle B are moving in same direction. So at certain stage, so particle A is impacting on particle B, and after that again particle A and B get separated. So we can say first is your before impact case. So here is at your impact, during impact case, and after impact again separation case. So According to this ratio, E is equal to VB upon VA. So velocity capital VB minus VA, it is nothing but velocity after impact, or we can say relative velocity of separation, and UA minus UB. So this is nothing but the initial velocities of both the particle, or we can say relative velocity of approach, that is relative velocity before impact. So this ratio, so value of E, you can say it is 0, or E is 0 to 1, or E is equal to 1. So if E is 0, it means type of impact is plastic impact. E is equal to 0 to 1, it is your semi-plastic, or you can say semi-elastic impact. And if value of E is 1, you can say it is your elastic impact. So these are the three types of impacts that you can find out by using this ratio or coefficient of restitution. Now types of impact. So there are four types of impact. So perfectly elastic impact. Perfectly elastic impact means if two elastic bodies collides on each other. So here are the properties. So first property says after impact both body regains their original size and shape, because it is elastic. So elastic material will regain its original size and shape again. Momentum is conserved. So for two particles, for particle A and B, before and after impact momentum is conserved. So for elastic body there is no loss in kinetic energy. So we can see kinetic energy before impact is equal that of after impact. So for elastic bodies coefficient of restitution is 1. So these are the properties when two elastic bodies are colliding on each other. Second type of impact is partially or semi-elastic, or we can also say semi-plastic impact. So after impact, as bodies are semi-elastic or semi-plastic, so they will not regain their original size and shape completely. Certainly they will regain their size and shape in partial manner, but not completely. Momentum is also conserved. So before impact and after impact momentum is conserved, but there is slightly loss in kinetic energy. We can say kinetic energy before impact for both the particles is higher than after impact. So ratio of coefficient of restitution is between 0 to 1, and both the bodies will separate after the impact. Next impact is our perfectly plastic impact. So the bodies are perfectly plastic. So during impact there will be damage to the shape of that bodies. So there is permanent deformation during impact, and both the bodies will couple together and move with common velocity. So there is change in momentum. So before impact momentum is same, but after impact, as the bodies are plastic bodies, so mass of both the bodies will get added and both the bodies will move with common velocity v. As there is permanent damage to the bodies, so there is loss in kinetic energy. So kinetic energy is not conserved for perfectly plastic impact, and the value of coefficient of restitution, it gets 0. Both the bodies will move together after impact. And last case, impact with infinite mass. So there is one popular example of impact with infinite mass. If we are dropping ball on hard surface, consider ball A that is dropped on hard surface B. So For this case, law of momentum, it is not applicable. There is loss in kinetic energy and coefficient of restitution. Now in this formula, there is certain changes because we are dropping ball on hard floor. So velocity of floor before and after impact will be 0 because floor is steady. So velocity before and after impact will be 0, and mass of floor is considered as infinity. So by comparative to the mass of ball, mass of floor is infinity. So by putting the values, we will get ratio E is equal to minus VA upon UA. So just finding the velocity, UA is under root of 2g h1. So height of falling, that is h1 height, and VA is equal to under root of 2g h2. h2 is nothing but the height of rebounds. So if you are placing these two values on this formula, so we will get E is equal to under root of h2 upon h1. So this is final formula that we can use to find the coefficient of restitution. So thank you.